All right. Can everybody hear me? I hate using microphones. So I'm Jeremy, and I know it's really hot in here, and it's the last talk, and everybody's ready to go. But you know what's hotter than in here? F sharp. So we're going to talk about F sharp. And specifically, we're going to talk about getting productive with the F sharp stack of happiness, featuring, hackiness too, featuring Suave, Fable, Fake, not with an S, and Packet. And like I said, I'm Jeremy. I'm Mr. J Abbott on Twitter. My Twitter handle says two-gated function, and I did borrow that from Mean Girls, but shout out for Mean Girls if you grew up with that. So I've been doing .NET development for about 10 years. I'm a functional programming hobbyist. I don't get to do it a lot in my day job, although I try to inject it in there as much as possible for my team, much to their dismay, I think. And then I'm also trying to spread the happiness of F sharp in my own small way, which is why I'm here today. Let's see. Cool. So the slides are on Azure, and I've got some scheduled tweets that are going to go out with links to those, and they'll show up on the Slack channel also, so I'm not going to go into that too much. So the F sharp stack of happiness has everything. Shout out to Stefan. Who knows who Stefan is? All right. I had to watch some YouTube videos of Stefan after I made this because he's hilarious. But anyway, it does have everything. And what I mean by everything is it's full stack F sharp on the back end, the front end, the build tools, your dependency management, all of that is F sharp. So I also have hot reloading on both the client and the server, and I think we're all more or less familiar with what that means. But in general, it lets you do an edit, and it watches your code, and it reloads it for you so that you're not having to like save and hit F5 and whatnot. It makes it a lot more productive. So on the back end, we're going to use Suave running on .NET Core. On the front end, we're going to use Fable to write our client-side code, and that's going to get compiled down to JavaScript for us. We're going to use Fake for our builds, Packet for .NET dependencies, and we're also going to look at some shared code between the client and the server. And the best part, of course, is it's F sharp all over the place, and it's all open source. So why are we doing this? That's a really important question. I think that you always get that question when you're talking about F sharp, and I've already got C sharp. The main reason for me to want to use this stack is because there is more of F sharp. F sharp has pattern matching, algebraic data types, defaults, immutability. I know like C sharp 7 has pattern matching, but F sharp's is better. If I'm using this stack, I don't have to write actual JavaScript. I can use the same language instead. I don't have to worry about like what this keyword is in this specific instance, which I think is a win every time. And then again, shared code between the client and the server, and so I'm more productive. So we're going to talk about Suave first. So we're going back end to front end, and we'll look at the tooling in between and how these some of these tools intersect. Suave is an F sharp web framework that is built around the philosophy of modeling your application as a series of functions. It encourages you to think of your application as a series of functions. This is a really basic example, and we're going to look at some actual code for it too. I've also got Zoom it enabled, so if you can't, can you all see that if I mouse over it? All right. So this is a really basic hello world example. I have a couple of values here. Simple app is a value that basically returns a 200 with hello Portland. And then I have a more useful or perhaps more meaningful example that's also a value that is really the composition of several smaller values that are of a similar shape. But even if you don't know F sharp, you can sort of look at this and reason about what's happening. You can kind of infer that I have a get with a path of hello is going to do something, and I can probably reason that that's whatever this is. And the same thing with a post. I can see that a post with the path of goodbye is going to do this. And so Suave gives you like this really semantic way to reason about your web applications and create these pure functions where given an input, you get the same output every time. So before we look at an actual demo of this, I want to talk about one of the core concepts behind Suave, and that is the Webpart. And in this example or this slide, I have this type alias for a function called a Webpart, and this function accepts an HTTP context and returns eventually an async HTTP context option. So if you think about how the web works, when I send a request out, I may get something back eventually. And that's kind of how to think about a Webpart, right? Something comes in, and assuming that everything happens the way it's supposed to and the request is well formed, I get something back. So a Webpart really models that for you. And Swab is built around this idea of composing this pipeline of functions. So let's look at some code for Webparts, or for Swab, rather. All right, so this is running on .NET Core, like I said, and I'm just going to run this little project down here from the command line. I'm using Visual Studio Code for everything that you're going to see today with the Ionide project for F#, so I get lots of really great tooling built into Visual Studio Code. And if I hit enter in the right space, things will happen. So once this builds, it's listening on port 8080. We can make it, before we jump into it, let's look at this in, for real though. So I have simple app here. Like I said, if you look at the type, it's actually just a web part, which we just talked about. The function successful.ok accepts a string and returns a web part. In this case, that string was hello Portland. And then down here where things get really interesting is I have this other web part called better app that's the result of calling the choose function with a list of other web parts. So I have get, which we kind of talked about, and that just matches on a request. If it's a get, it can go to the next thing. But how do I go to the next thing? I have this little fish operator here, which is a key part of how Suave sort of lets you compose your application. And this fish operator is a F# custom operator that accepts a web part, and if that web part returns some instead of none from F# options, then it will actually call the next web part, which in this case is path hello, and then I combine it again with the next web part. So as long as each of those returns something and not nothing, I can keep going. And so the way this choose works effectively is if none of these ever actually matched all the way across and I got an actual sum back, it would not return a response. So we can go take a look at what that looks like in practice using Postman. So let me pull that up here. We're on 8080. So nothing exciting happening. Hello Portland. I can say goodbye as a post. And I get a response back. Now if I made this a get, which we don't have an actual web part for, I get no response back. So that's just sort of, I'm going to zoom in on that. Let's see. So that's me doing a get with against something that should be a post, and I don't get a response back. Let's see. And so that's kind of Swab in a nutshell. We're going to see a more actual complete application in a minute to sort of really explain this better. But I just wanted to give you like a brief idea of what that looks like. All right, so let's talk about Fable. Fable has a great name. It's F# and Babel combined. And so the idea behind it is I can write my client-side code in a sane language, and then I use Fable to transpile that to JavaScript. I was working on this talk, and I saw this tweet, and it made me laugh. I use TypeScript at work. There's lots of options to get around some of the nuances of JavaScript. And this tweet really made me laugh. And it was basically, the joke is, do you feel like you type a lot more with TypeScript? And I was emphatically saying yes when I saw this. And there's a couple of examples here that I'm not going to get into due to like time constraints, but the gist of it is, even with like some of these other static typing tools to help you with JavaScript, bad things can still happen. In this case, the commutative property of addition isn't really respected well with TypeScript, and it is kind of with Flow, which is Facebook's kind of version of TypeScript. But if I use something like F#, where I have an addition function, int goes to int goes to int, and I try to use it in a way that doesn't make sense, specifically in this case, like that operator does not work with these types, things are wrong on every level. The function definition is like the F# compiler's type inference is like, I have no idea what's happening. These are like, I have no idea what's happening. Somebody like help what's going on here. And I get this, at so many different levels before it actually gets to production, whereas even TypeScript isn't saving me every time. So that's pretty cool. So how does this actually work? So Fable basically makes use of Webpack to take my F#, use the Fable loader as part of Webpack, convert that to ES6, and then Babel to convert that to ES5 so that it can actually run on most browsers. So like I said, it does depend on Webpack. It also integrates with the existing JavaScript ecosystem, and we're about to see a sample of where that happens. And then it also depends a little bit on Packet on the .NET side, so that I can get other like type definitions, if you will, so like a React type definition for Fable. And we're going to see an example of that as well. And we'll talk about that in a second, but let's go see some code. Let's close this out. Switch to this one. And I'm doing something a little similar here. Fable makes use of the .NET SDK's CLI tooling, so I can call this command inside of the command line. It's .NET Fable npm run start. And so .NET Fable is part of the Fable tooling. And then these are some commands it supports. In this case, I'm just starting like the Webpack dev server and also like the Fable server for processing that, the Fable to JavaScript. So if I run that, while that's happening, we can start kind of talking about some of this code so y'all aren't waiting too much. What really doesn't take that long. But in this case, I have a simple app here with an init function that I'm calling. One thing I like to draw attention to immediately is if I just looked at this and I didn't tell you we were looking at F#, it's pretty much semantically similar. So there's not like a huge learning curve initially to deal with like the JavaScript ecosystem and even the most like basic examples. Before we dig too much deeper though, let's go actually look at what's going to happen here. If I can, let's see. Sure, we'll just go open a new browser. All right. So this is my super complicated Fable sample. I have an Xbox. I have a text box for X and a text box for Y, and if I hit add, I get an alert that, and it sets the result there. Not anything super complicated. But this example, the whole goal of this example is to sort of demonstrate interacting with the DOM using like the native JavaScript functions, but also using something else that I think is really compelling as a reason to use this. So I have this randomized function inside of an F# module called utilities, and what's really cool is this F# module, I'm writing it just like I'd write regular F#, and Fable handles packaging all of these things together in a way that JavaScript understands. So I can be as productive as I want to be in a language I'm more comfortable with, as the case may be. But I have this randomized function, and I'm using system.random right here. And this is system.random from the BCL. This isn't like something like magical, which is really amazing. So Fable's going to transpile this down to something JavaScript understands, and it's not actually using like the native random number generator. It's using something else in this specific case. But the takeaway here is there are a lot of .NET types that you can use that will get transpiled down to something JavaScript understands. So again, that whole like I'm comfortable with this ecosystem. I know how these things work, and I can just keep using them is kind of key here. And then I have like get by ID. In this case, I'm getting like the X like input. What's really neat is this is strongly typed. So if I mouse over that X, it's an HTML input element. So I get specific things I can do off of this, like set the value property, which I wouldn't do without that typing. But it's pretty cool that it's all statically typed. And then on my click event, there's not a whole lot interesting happening here, other than I'm just adding these two things together and setting a value. The only reason I bring it up is to just sort of point out again something along the lines of window.alert is very similar to what I would do if I was writing regular JavaScript. So again, that learning curve isn't too bad when I'm just trying to get started with Fable. And it's a lot of fun to play with. The last thing I want to show on this is if I were to like uncomment this, oh, whoopsie, that works too. Okay. Why is that happening? All right. Okay. There we go. I get my fun compiler warnings all over the place. So let's put that back because I don't need the help right now. Last thing, at least this comes from the Fable, this Fable sample, which you can create like yourself. If I do .NET new Fable, I'll get this sample. You have to install the tooling first, or install those templates first. And there's some links to that I can tweet later. You'll get this out of the box. And the reason this is really cool is it's just another example of, hey, these are built-in parts of JavaScript that I'm able to write in .NET, and again, in a language I'm more comfortable with. And so one last thing to talk about with Fable is, because people are going to ask this question, is that compatibility grid. So let me zoom in a little bit here. let's see, make that bigger. What happens with these different types when they go to JavaScript? So instead of me like answering questions that I may be wrong about, I can look here and see what's happening. So it shows some of the types that are supported and like what they're going to turn into. And it also explains some caveats. All numeric types become JS number, which we probably could have inferred on our own that that's what was going to happen. But it's pretty neat. So if you guys are curious, there's some documentation here about that, or we can talk about it after this. So let's go on to the next piece. All right, so we've kind of reached the point where like all of these little tools we talked about sort of intersect. And that's the Fable Suave Scaffold, which is an open source GitHub project based on real life production code. So this isn't like some ivory tower idea like, hey, use these things together and see what happens. People are using this to make like productive real business applications. It encourages an edit, save, recompile workflow, which is what I was referring to with hot reloading. This specific example, and you don't have to do it this way, but this specific example that we're going to look at leverages the Elmish architecture on the client with React also. You can also use React Native if you're doing mobile apps. And that the same people who contributed to make this template are doing React Native apps as well. So it's running on .NET Core and VS Code. You don't need a whole lot of heavy tooling. Just like what I've been showing here, I'm just running on .NET Core on Visual Studio Code on a Mac. And is there anything else? Shout out to Stephen Forkman. He created Packet, which is an alternative NuGet package manager. It also manages HTTP and dependencies and GitHub dependencies. Probably not right now because GitHub is a little meh. He's also just an amazing F-sharper. The whole F-sharp community is super friendly and welcoming. If you have any questions, they're really great. I love talking to them. So let's see, we're good there. Let's look at how all of this works together. Let's see, this one, awesome. And on this one, instead of like calling .NET directly, I'm going to call a build script with the command of run to get everything started. Before we do that, let's make sure I killed this because otherwise I may have some ports blocking each other, which is always fun, especially in the middle of a talk. Right, cool. Let's run that. And while that's running, let's look at some of the benefits of using this even before, like, while it's doing its thing. So I have inside of Visual Studio Code right now, I have this shared folder called domain, and I have some types in here. And this is one of the reasons, first off, to use F# in general, in my opinion, are record types. If I think about like my C# day-to-day work, that's like probably a file for each of these, and it just doesn't feel as productive. I love record types. It's probably one of my favorite things about the language. And so I have all these like little domain types right here. And what's more interesting though is how they're used. So, well, that's loading in the wrong space right now. We'll come back. So I look at like my server fsproj file. This is using the .NET Core tooling. I see that it's being referenced right here under shared domain. And then if I go to my client project, which is my Fable project, I just want to point out that it's also being referenced right here. So they're both sharing this. And so if you really think about like your typical web app scenario, I've got like a client that's probably all JavaScript now with like a RESTful API behind it. That response that's coming back from the server is going to need to be modeled on the client somehow anyway. And I see a couple of things happen. A lot of times with TypeScript, people are like, well, I'm kind of lazy and I don't want to actually explain what this type is, so I'm just going to use any, which is a great reason to not use TypeScript at all, just use JavaScript at that point. In this case, I don't have to worry about not being dry and having to recreate this model in two places. It's already done for me, so that's pretty cool. And we're going to show, I can actually show you right now how that's used. So I have this wish list F# file. This is on the client, and we're going to look at what's happening in a minute. But if I look for where my model actually is, this is the wish list from that shared code right here. So my client-side model gets to reference it directly instead of me writing it twice. Which is great for a million of reasons. I don't want to sort of harp on it. I think the term dry gets overused a lot because sometimes it's not appropriate to share that code because then you have dependencies forever and you regret it for the rest of your life, or at least as long as you work for that company. And that's somebody else's problem. But in this case, it seems pretty valuable because we've all been in that scenario where it's like, well, now I have to add this property to 5 different types, and it doesn't quite feel right when they are always going to be models of each other. So this is really cool. Let's go look at what that what actually came up, though. Let's pull up Chrome. Shout out to Pikachu. If we have time at the end, I'll show you my Pikachu tattoo. I have a problem, you guys. All right. So this is our, this is pure, all directly from the template. I didn't tweak it a whole lot other than like on a separate project. But in this case, I created a book, and then my friend pointed out to me the Expanse isn't a book, it's the series, because he's a smartass. But it was still helpful feedback. Anyway, I could go remove that and add in something like Leviathan's Wake, if I can remember how to spell it. And I don't remember right now because I'm on stage. Yes, thank you. You are my favorite person. TV show is really good too. I know that's not related, but anyway, here we are. I added a book to the list. And so let's go look at that code again for a second, though. Again, we're kind of using like React and the Elmish architecture. Redux was influenced by React, and it sort of kind of has the same sort of idea as what we're talking about here with this, like updating something and immutability, so in pure functions, right? So with React, I'm passing messages, and the view is updating as a result of that message being passed. So without digging too much into it, because this isn't like an Elmish architecture talk, I do want to show you like how that markup gets generated. And when I first saw this, I really struggled with it. And the reason I struggled with it was it's like I didn't like React at first because I'm like, oh, my markup's mixed up with my code, blah, blah, blah. But when you start thinking about pure functions, I kind of do like it. The other thing that's kind of weird is, oh, we're using square brackets instead of angle brackets. But I wasn't able to say it that way at first. I was just like, oh, this feels really weird. But when someone said it just like that, like you're just changing your brackets out, suddenly I didn't feel as bad about it, and I was able to read it with a little bit more clarity. So that's really what's happening here, right? I have a div, and I can mouse over that and get my F# IntelliSense, and this comes from Fable Helper's React library. I can give it some attributes, and then just like HTML, it's just more elements underneath of it all the way down. And so that's what we're rendering on the client. Let's see, is there anything else I want to talk about? Yeah, let's talk about, how much time do I have? A little bit. Let's see. Now we got all that. We can go ahead and move on to how some of this stuff works. So we're going to talk about fake a little bit for a second. Fake is a F# make. So you have cake, you have fake, you have Saki. There's lots of different ways to make or to build your tooling. You can use MS Build directly. Fake is one of my favorites. It's a domain-specific language for creating your build scripts, and it's all in F#, and I've used it on quite a few projects. I really like it. I'm not going to go into everything it can do, although I want to point out that like you can like do your Docker whatever and also, everything else. But the key piece I wanted to talk about is how the piece that makes this whole flow kind of work, where I can edit my server and client code and get that recompile and keep going about my business. And that's this run target right here. And this run target is doing three things, and let's not, like, IntelliSense isn't helping me quite right now, or the tooling. I'm running .NET Watch Run, and I'm also running Fable Webpack Dev Server, and then I'm opening the browser. So the two that really matter here are these async workflows for .NET Watch and Fable Watch. And with those running, I just have those two things running in the background and doing their respective watches for my changes. And that's just a target as part of fake. And so one of the cool things about fake is the way that it lets you define targets and how they depend on each other. So in this case, I have down here this run target, and it depends on install client. Well, what does install client depend on? I can go up here and I can see, well, it depends on install server, which depends on install .NET Core, which depends on clean. One of the ones that's really interesting to me is the install .NET Core task. And let me go find, oh no, install .NET Core. Cool. And so the reason I think this is interesting is because Fake actually has the tooling built in to do that for you. I don't have to like do anything special. It's just there as part of Fake. So I thought that was kind of neat, and I wanted to call out that. The other thing I want to talk about in the little bit of time we have left is Packet. So Packet is an alternative dependency manager for .NET. It's not just about NuGet. Like I said, you can also reference a GitHub repo or an HTTP endpoint. And I wanted to show what that looks like in a project, a more meaningful project than the other ones I was showing earlier. So let's clean up everything a little bit for a second. Packet makes use of 3 different files, ultimately, for everything to happen. And we're going to start at the project level and work our way out. Everybody's really familiar, I'm pretty sure, with like a package.json, or not packages.json, but the packages.config file. And we'll look at the server one first. And so the alternative in packet is a packet.references file. And you can see here that I'm depending on f#.core, swab, and a bunch of other things that y'all can read if I zoom in and show you, but I'm not going to read all of those. And that's cool, and you're probably wondering, like, well, what's the version number? What's all happening here? And those are really good questions. Well, at the root of my whole project here, I have 2 other files. I have a packet.dependencies file, and I have a packet.lock file. So let's look at packet.dependencies for a second. Packet.dependencies is like my one-stop shop to see what all is actually depended on throughout this entire solution. I'm using the term solution loosely. It's not a .NET solution. It's just this thing as application. And so I can see, like, at a high level that I'm using these projects from NuGet. And then also I can, I have a few more here for Fable. And also I can group dependencies based on where they're using the application. So if I'm ever curious about, like, why is this package here, I have a better idea. So, like, it's pretty safe to reason about. These are probably all application level needs. And then these are specific to, like, my testing framework. And this is specific to build. So, like, it's actually my NuGet package for fake. So that's pretty cool too. The coolest part of Packet is the packet.log file, and it's cool for a few reasons. One, it gives you a guaranteed repeatable build using the exact version that you're expecting for each of your NuGet packages, but also because of this amazing graph it gives you for transient dependencies. So a transient dependency, for everybody, just to be clear, is a dependency that the package you asked for depends on to be able to run. And with being able to see it this way is probably one of, like, the best features. It also gives you the exact version that you're using or something close to it. And I can see what those dependencies are all the way down. And there's quite a few, obviously. That's kind of the world we live in now. But it's nice being able to see them right away. That's one of my favorite parts of Packet, I think. This template gives you a few other things also that I'm not going to jump into, but, like, it does have a template for your Docker file and whatnot. So let's see. Is there anything else? We already talked about Packet. We already talked about fake. All right. We haven't really been doing questions, but does anybody have any questions? And can you speak really loud if you do? All right. It's super hot in here and everybody wants to go. So that's all I have. Thank you all very much.